Hello, hello. Welcome. How is everybody doing? My name is Jason Hand, and this is All Around Azure, and I'm really excited to be here with you. We've got some really awesome stuff to show off today, and we've actually got a repeat guest, my first repeat guest, who's going to be joining us. But while we're getting connected here, I'd just like to tell everybody if you got any questions, add those into chat. We're also trying to get things set up so that we're restreaming over to Learn TV, which should be working here momentarily, we believe. And while we're getting that set up, I'm going to go ahead and introduce our guest here. For those of you who've been watching the show before and keeping up with everything that we're doing here on All Around Azure, please welcome back my good friend, Cassie. Cassie, are you there?
I'm here. Hello.
Hi.
See me okay?
We can see you okay. Everything seems to be working now. Cassie and I were doing a little tech check earlier and decided to go ahead and just restart everything just to play it safe. We were having too many little wonkiness things, but that's how it goes on these streams. So thankfully, Cassie and I have been through that before. It's not too much of a panic, but also we may continue to have problems. So we will just kind of deal with them as we go through. So one of the things. In fact, we might be still sort of experiencing our little slowdown. Oh, are you there, Cassie?
I'm here now. Yeah, you were cutting out for a second. Was I gone?
Yeah, kind of some of the same stuff that we were seeing earlier. So we'll just deal with it, and hopefully it's not too much of a problem. But bandwidth is just always one of those deals. So Cassie, how are you? Sorry, with all this, I'm feeling a little scattered, trying to make sure everything's plugged in and going to the right place and working. How are you, my friend?
I'm good. I'm good. It's Monday. We get to talk about natural language processing and
exactly. I love this shirt too. It's not just pink, which is very on brand for you, but well, tell us a little bit about some of the stuff that and by the way, this is just coffee in my cup. I don't know what you've got. I know we're going to be talking about wine today, but what type of things are we going to be using wine to illustrate interesting things in machine learning? Like, give us the goods on what we're going to learn today.
Yeah, so we are going to build some models that will look at the description of a wine, so of a sommelier. And if you're not familiar with what a sommelier is, it's actually somebody that goes through very rigorous training to be able to pick out all of the intricacies of wine down to like region, the date or the year that the wine was created, the vintage, and many other things. And it's a really actually hard thing to accomplish. And so I thought it would be really cool to take this data set that I found on Kaggle, which is a place that has a lot of cool data science resources, that was scraped from the Wine Mag site. And it's basically all sommelier description.
Oh. I think we might have got her froze up again here.
Of Cabernet or a champagne or sparkling wine or those types of things. So we want to see if we can be able to pick out these values just from the text description of the wine.
Mm-hmm. And also real quick, Cassie, you kind of broke up there for a little bit, but you're talking about sommeliers and being able to just have that expertise on all things wine, like where it came from, all the different like hints of whatever you find in there, the process of making it. Like, it's not just a matter of, having had enough experience drinking wine that you have an opinion. Like, you actually know this stuff inside and out, right?
Yeah. And it's a super grueling process that they go through. There's a really good, there's a show on Netflix as well I think it's called Somm. Really good. And they go through, they follow these three people going through trying to pass this master sommelier test.
Oh, wow.
So cool. It's pretty cool if you're interested in learning more about that. So what I've created with these models is a game called Somm Wine Game. So this is just a site that I put up in order to play with the models through a UI. And so essentially what you would do is, like, if I'm drinking a wine and I want to pretend I'm a sommelier, I would start typing my description of the wine, and then I would hit submit. And then what it actually does is it takes the text entered. So since I didn't enter, it's just going to take this placeholder text that I have.
Mm-hmm.
It posts it to the models that I'm going to show you how we created them today. And it gets 3 different models, actually, one to predict price, one to predict points, and one to predict variety.
Mm-hmm.
And then it's going to return back what it thinks the highest probability is based on the description. So for this one, it thinks, and 5 is the highest score you can get. So I converted the percentage into a wine bottle scoring system. So this one is a rosé, and it's from 81 to 90 points, and the price is from $1 to $20, and that's correct. Okay. So it does really well on this particular one. So one thing that you can do then is it's kind of fun to come in here and see how good you can describe your wine. Mm-hmm. and see how well you are a sommelier, which is kind of cool. The other thing that you can do with this particular site that I put these together for is you can come in and like, maybe you're not sure what you're in the mood for. You could like put the flavors that you're in the mood for and see what comes back like for the type of wine that you want to drink.
Nice. By the way, one of our colleagues, Frank, is on the chat stream. Oh, Cassie looks like she's jammed up again. Hi, Frank, and glad to hear that you've got your nice glass of red wine there to join us in all this. Looks like Cassie's continuing to have some bandwidth. Oh, now we're back. And we're back.
Am I back? Okay.
You're back. Okay.
I'm not sure where I cut out.
Nah, I know. This is it's going to hopefully not be too much of a problem. But I feel like we have a lot to get through to like show off all this stuff. Should we switch over and you can start showing off some things? What do you think?
Yes, and actually, let me make sure. I'm going to make sure my son isn't streaming much right now because I'm wondering if he's doing anything that might be affecting this.
He's got to shut off the Xbox for a few minutes.
That's actually exactly what.
Okay, well we can give you just a minute if you'd like to do that. And thank you to all of you who are joining us on chat. I hope you had a great weekend. And the stream today, we thought we were going to get it up on Learn TV, but we maybe have the timing off just a little bit. But we're definitely doing fine over here on Twitch and really excited. I'm going to be actually hosting all week because Frank, who's chatting in with us in the chat there, is not doing a very good job of taking his vacation, although red wine might be somewhat better there. But I'm filling in for Frank all week, or splitting. Usually he and I split time between the three of the shows each week. So anyway, I'm excited to kind of drive this car for a couple of days this week, and really excited to have Cassie on just because we've always, every time we do this, it's so much fun, and we got a lot of good questions and engagements in chat. So
yes, okay, so I've sent the message. It's off. Hopefully that resolves it.
He acknowledges it, says no problem.
Yep.
Awesome.
So hopefully that's what was.
Hey, excellent.
Software engineer, so I kind of approach machine learning from like a software engineer background versus more of an academic, which tends to be more traditional. Although I think there's a lot more self-taught people coming into this field, which I think is pretty cool. So I love Microsoft technologies, obviously. So I'm going to start here in my Windows terminal, which is a command line front end. Are we sharing my screen?
Yeah, I am. I just switched it over. We might need to go a little larger on the text there within terminal.
Yeah, there we go.
And in fact, I'm going to put the two of us. I'm going to put the two of us on the right side of the screen, so you've got pretty much the whole left 2/3 real estate.
Okay,
but
so
good.
that should be better now. So this is the Windows terminal. It's a command line front end that allows me to add different terminals, which I love because I am going to be using WSL today. So I have that. I also have Anaconda built in. So if I want to use my Windows machine to do machine learning, I can do that. And here I have the Conda environments all set up right in my Windows terminal. Rather than going to Anaconda prompt, I can actually do this right in my terminal, which is pretty nice. The other thing that I can do is use WSL, which if you're not familiar with that, it's a Windows subsystem Linux. So it allows me to run Linux on my Windows machine.
It's my favorite part of terminal. It's so nice. It's It's what
Okay.
like made me feel comfortable kind of coming back into the Windows OS world after years of being mostly Mac and Linux.
Oops. There we go.
And
Yeah. And that's, I always forget, I got to do ls instead of directory here. And so I'm in my Windows subsystem Linux, I have my Conda installed and also Jupyter Notebooks. So I'm going to go ahead and just start Jupyter Notebook in my WSL kernel. Yeah, I do love it. And the cool thing about it is if you have the most recent version of Windows, I think it's either the most recent version or it's the preview version. I'm sorry, I don't remember off the top of my head, but you can actually access the GPU.
mm-hmm.
So you can use the GPU for your training, but I don't have that one. But we're not doing anything that I need that optimization for. So we're cool. So open my workbook. This is the right one. And so this is going to open up my Jupyter Notebook that I have where we built out this model, and I'm going to go through it step by step with you.
Cool. And by the way, Cassie, we are restreaming or simulcasting over onto Learn TV now. However, it's not perfect. Apparently, there's a setting somewhere within our restream settings that is set to 720. So we're kind of just up in like this small little corner within Learn TV, but it's over there. So hello, everyone over in Learn TV world. It's nice to see you. Thanks for joining us. We'll get that figured out for the next show for sure. Appears to be some secret setting someplace.
Cool. So here is the Jupyter Notebook where I built this out. You can see that there's some extra text. I have all the descriptions and kind of like information in this notebook as well. So you can go to the GitHub and download it and play with it. So I'm just going to go ahead and run this. So to run different module or different cells in Jupyter Notebook, you just hit Shift Enter. Mm-hmm. And so I'm going to import my packages, and we're using Python. If you're not familiar with Python, this is it.
Who's not familiar with Python at this point?
What's that?
I said, who's not familiar with Python at this point?
Yeah, I mean, if you're new to programming, maybe.
It's a good one. It's a good place to start too, though.
It is. I think it's a really cool language to start with because it can kind of be like anything you want it to be, I feel like.
Mm-hmm. Yeah, and it seems like it's used both front end, back end, like multifunctional language. I'll find you a link for that Jupyter Notebook there. Let's see if I can find that while she's reconnecting.
But then I ended up starting to really, really like it, and I do really like it now. You can do things so quickly.
Yeah.
In it, like, and I've actually done something. So I've written it in C# and then written it in Python, and the Python was less code, so and faster.
Yeah, I hear those stories a lot.
It's taking a minute. All right, cool. So we have imported our package, and then I have this data set, and I mentioned this Kaggle site earlier. I'm going to go jump over here. And so this is actually where I got the data set from. And they went and they scraped the data from the YMAG data site, like I was saying. Mm-hmm. And if you go into here, this is also a really good spot to start if you're getting started with data scientist or at being a data scientist or learning about machine learning. If you're looking for data sets, this is a fantastic place to start and go look for data. So I like to look here and see what fun things are out there that are open for people to use. So we'll go back to here. And so that data set is a CSV that I have just linked to my GitHub. So I'm actually using my GitHub as a content or as my storage for this particular one. And then I'm going to be using something called Pandas. So Pandas is Pandas data frames, or it's a library that you can use in Python and use the data frame. And if you're from a C# background, it's like the data table essentially. And so if I run this, what it's going to do is it's going to load this CSV file. It's going to read it into a data frame, and then head just prints those first 5 rows so I can get a quick peek and make sure my data loads the way that I want it to.
By the way, I put some links into the chat for everybody. I put a link directly into our notebooks so you can learn more about the Jupyter Notebooks and how those work. within Azure, and then Kaggle as well, which is that repo of, I guess you'd call it a repo, right? Of just like a lot of large data sets that you can sift through and find one that, kind of suits your needs.
Yeah, and then there's also like challenges that people have submitted different solutions for. So companies will create challenges and they can say, hey, we want you to solve this for us. Here's our data set. And then you can kind of gamification.
Awesome. Yeah, I remember looking up something. I think it was you and I actually. When we first started talking about doing something with AI and music. I think you shared with me the Kaggle or the Kaggle, and I went and checked it out, and just looking for stuff related to music. Like what we know, like over on Discogs, like we can extract a lot of good information out of there. But like, how can we get some different ones to start filling in the gaps between what information isn't available on Discogs versus what we know versus what else is out there? So it's a really neat site. Everybody should go check that out, especially data scientists that haven't heard of it. And we're waiting for Cassie to come. Oh, and I think you're back now.
Oh, there. I think I'm back now. Sorry, like cut out. So we were talking about Discogs and getting data set for music machine learning, right? And
yeah, I think you were the first person to expose me to that site when we were talking about all the different fun things we could do with our like record collection or who knows what.
Yeah, there's a lot of open music data sets. Spotify has some APIs as well you can sign up for that they'll let you use. I'm actually working on a machine learning model right now for some audio data sets that it's not working yet, but I'm excited for it. It's a cool way to look at audio classification and how to understand audio data. So a lot of machine learning is all about the data, understanding the data, cleaning it, getting it ready. The actual like building the model part is like a lot smaller percentage of the time you spend. It's a lot about the data and getting it ready.
Exactly.
And finding it, sometimes labeling it. So this is, you have supervised machine learning and unsupervised machine learning. So with supervised machine learning, we have our features and our labels. So our features are the data we'd send in, and our labels would be what's being predicted. And so this is a supervised one. And so with that, you have to label all of the data. If you don't, like this one's already labeled for us. And I'm actually going to do some manipulation to the data to create new labels based on the content that exists already in here. So labeling that data and getting it ready can be a very time-consuming part as well. All right, so our data printed out here. And so if we take a look, we can see the different columns that are available to us. We have country, description, points, variety, provenance, region, who's the taster. So the person, this is actually the sommelier giving the description. And then we have the title, the variety, and the winery. So if you look at this, I mean, there's other things you could probably play around with, like can you predict the region? Like I said, we're playing with points, price, and variety, but there's definitely other things you could think about using this data for.
Yeah.
So once we have the data loaded, we can start to visualize our data. So this is a big part of data science too, to help you understand your data application, which is ending up, this is a multi-classification, then it can be unbalanced. So you want to kind of look at how things are looking in your data, how many items you have for each particular class. And in our class, it's our label. So that would be like price, points, and variety, if you didn't know what class was.
We also
and then each of those have classes as well. So
yeah, we had someone comment on in chat, Cassie, about how the Azure notebooks are kind of going away, right, this year, and switching to some. It's still Jupyter notebooks, but you have to do them some different ways. Do you know anything about that, other than what?
Yeah, I can speak to that. Yeah, Jupyter, the notebooks are going away, but we do have it still in our Azure machine learning service. So if you went into Azure portal, you can create a Azure machine learning resource. And then in here, we have different notebooks. So you can set up a compute. And from this compute, I can run Jupyter or Jupyter Lab right from my machine here. So I'm actually running it in the cloud. So it's still a cloud notebook. And I'm not sure if you can see that. Let me just put this in the chat quick. So I went to ml.azure.com. Now, if you haven't created a resource yet, there wouldn't be anything in there for you. So you'd want to go to Azure first to create that resource. But then once you are here, you can see I've created a compute instance. So I have an NC6, which is a good machine for starting out. It has some GPU, and then I can go to click on, let's say, Jupyter Notebooks, which will bring me into the notebook experience. So now I'm still able to use a cloud Jupyter Notebook, but now I'm able to define the type of machine I want to use. You can add, the power that you want to add for that.
Yep. We lost you again, Cassie.
Oh.
Put you back.
I'm back? Okay.
Yeah, I can't tell if you can tell. No, I don't believe so. You were just going over what was in that one VM as far as GPUs and the resources.
Right. So yeah, I was able to use that that VM that I created in my Azure Machine Learning resource. And then from there, I can open up, RStudio or Jupyter Lab, and I can then be using a cloud VM to work on my machine learning model.
Yeah. And also, can't you, I want to say inside Visual Studio Code, you can run Jupyter Notebooks or interact with Jupyter Notebooks in a very similar way, right?
You can. Yep. You can use VS Code to run your Jupyter Notebooks as well. And then, I haven't actually tried connecting it to this cloud VM, but I don't see why you couldn't, because if I had set up SSH, I'm fairly certain I could just SSH into this machine just like you can with any other cloud VM,
right.
And then run Jupyter Notebooks on it locally in my VS Code instance. I haven't tested that, but I don't see why that wouldn't work.
Sounds right.
Cool. So yeah, so there's definitely still options to use Azure Notebooks. It's just going into the Azure Machine Learning service. And if you're not familiar with that, I can give you just a quick overview of the services we have in here.
Yeah.
So we have notebooks, and so your different notebooks that you have available, you can actually take a look at them in here as well and visualize what's happening. So that's outside of actually opening up the Jupyter Notebook instance. Now, I've never actually tried to run them in this UI, but I think you can. It looks like it's running on my portal. Now I got to try this because I've never tried. Yeah, cool. You can run it right in this UI. Excellent. That's really neat.
Yeah.
So yeah, you can run it through this way, just going through your different notebooks. You can open it up in that new, if you like the Jupyter Lab UI, you can do that. And then you also have access to, where is, that's not what I wanted. There's a code, a terminal in here as well. And I just forgot how to get to it. I think they changed it. So anyways, there's also a terminal so you can interact with it. Ooh, is this little, does that get me a terminal?
Yeah, that looks right.
This one, it's this button, this plus sign. So in this launcher, then I can go into here and I can choose the type of notebook. I can go into terminal and I can, select my Conda environments and all that kind of stuff. So you have all that functionality here. And then, so if I go back to the machine learning, Azure Machine Learning service, we also have AutoML. And if you're not familiar with AutoML, it's kind of like machine learning for machine learning. I can just give it a data set and tell it what I want it to predict, and it'll actually figure out the best model for me by going through different algorithms and hyperparameters and then giving me an output of and a model. And then I can then basically just deploy that. So you can create a machine learning model without writing any code, which is really cool.
Yeah.
The designer.
That's kind of how I got into it.
Go ahead.
When we were creating all that content for the tour, Ignite the Tour last year, that's kind of how I got into all that. I was doing a session on automated ML, a lot of hyper parameters tuning.
Yeah. Yeah. And so we actually have that. There's a service that you can use for hyperparameter tuning called Hyperdrive, which you can use in your Jupyter Notebooks as well. And I don't know for sure, but I think it's using that same logic. So if you look up Hyperdrive, if you want help automatically tuning your hyperparameters for your deep learning networks, you can use that as well. So it's supposed to.
And there's some cool plugins too that will like visualize all the different like things that it ran and you choose like what the rules are that you want to set it up to do its tuning. It's really fascinating, actually.
It is, yeah. And there's a lot of good, I think, video content out there as well on it. But it would be cool to do maybe another follow-up machine learning one just on, auto ML
Absolutely.
for sure. So then Designer is another one that we have in the Azure Machine Learning service. And this one is creating a model without writing any code.
Yeah, and I'm just putting the link into chat for that right now too. Which is actually, as she's reconnecting, I think it's still in preview when I checked out that document page.
So we're in section, which is really cool. And I'll go back to this one. I was going to do this after we do the magic in Python. I was going to show you some of the magic of no code text classification with the Designer and Azure Machine Learning.
Okay.
But I built my first one in Azure Machine Learning Designer, so it holds a special place.
Exactly. So
it's a cool place to start.
Yeah, totally agree. And I just put a link into the chat for that. And it's when you go to the documentation, it says it's in preview still.
Yeah. So there was a predecessor to it called Studio. Now this is all the Azure Machine Learning is Studio, but there used to be something called Azure Machine Learning Studio, and that one was turned into Designer. And I think it's going to come out of preview soon. But yeah, it is technically in preview. They've been adding a lot of features, and it's I wouldn't be scared off by the preview. I know some people.
Yeah, I was gonna say it's been around for forever. It's just kind of going through some name changes. I feel like it's having a little bit of an identity straightening out of like, what are we? I mean, using that term studio in a lot of different places, I think it's confusing.
Totally.
So yeah, I don't think preview means like this is early. I mean, there's some really newer things in there, but in general, this is something that's been around a while.
Yeah, for sure. So I'll come back to Azure Machine Learning. I kind of went on a little tangent there just to show you where those services are, and we'll come back to this, and I'll kind of talk more about this model and some of the other features in there. But yeah, you definitely can still use Jupyter Notebooks on Azure through Azure Machine Learning. Okay, so let's go back to...
It's funny to me. It doesn't seem.
Is the higher point.
Sorry, we lost you again.
What's that?
I was starting to like say something, and then you came back. I was starting to make a joke that I think there's still an Xbox game happening or something. Yeah. I mean, I don't know that for sure, but it's about the same as it was previously.
Okay. Yeah, I'm not sure.
It's okay.
Sure what else now. Okay.
I think we've tried everything we can, so we'll just push through. It's not that big of a deal.
All right. So in this one, we were looking at the graph to see on the left axis we have price, and then we have points. And you can see that there's a correlation. The higher the points, the higher the price, which if you think about wine, that actually makes complete sense, right? Totally. The higher the points, that means that it's rated as a higher wine, or it's done really well, which means the price is probably going to go up. And then here, this is just another way to look at it. So here we were looking at a bar plot, and here we're looking at a box plot. And so you can kind of understand your data differently by using different graphing libraries. If I were to go to Seaborn, I don't know if I have to do, it did come up, perfect. Go to the example gallery. You can see all the different types of graphs they have. So depending on the type of data you're using and what you're trying to understand and visualize, you can use different graphs. And I like Seaborn is pretty, I feel like, simple to use. So I've been having a good experience with that. I know, like I said, another popular one is Matplotlib. But there's good sample code in here as well. So if you're trying to figure out how to use it, you can go and check that out. So I can oh, she always has to make an appearance. She did this last time too.
Oh, your dog? Was she? Yeah.
Yeah, she's knocking on the door. Before she wanted out, if you remember.
No,
so
no closed doors in this house.
Now she wants in, so she's scratching at it and looking at me. Oh, she's funny. Okay. So here we have the cat plot. This is just another way to look at. So I thought it would be interesting to look at if the sommelier, so the taster, um, one was like more critical than the other. So like on the point side, like if you could see that like, well, one gives higher points than the others. I feel like you need to look at the amount of reviews too, which I don't have displayed here. So I feel like this isn't necessarily a good representation to see that. I think there'd be some other ways to visualize this data to make sure. But in this one, if you were not thinking about maybe the amount of reviews a particular person has given, you could kind of be like, oh, you know, who's giving better reviews than other ones. And so those are the kind of things that when you're looking at and visualizing your data and you want to understand your data, you just start asking those questions and figure out, you know, what can I answer with my data? So the next way that I'm visualizing it is through a word cloud, which I'm sure everybody has seen before. They're used a lot in data visualization, but I like to use this one as your cheat sheet to sound like you know what you're talking about with when you go wine tasting. So you could say, you know, it's the aggressive tannins, you know, or something like that, or the bold fruit in this Cabernet or something. You know what I mean? Like you could just grab different words from this.
Includes tropical rinds that add to the acidity.
Exactly. That was good.
Yeah.
See? That was amazing. See, and so all you need to do if you want to impress someone with your wine knowledge is take a look at this word cloud. Okay. So then let's take a look. Oh, so this is just again graphing out the data which we saw earlier, and if you could look at it now that you've kind of thought about some of the questions you could ask this wine. You know, I was want people to think about what questions would you ask? Like, what things do you think would help you understand how to build this model? Like, what would you want to see to understand how you could make a good predicting model, right? Because you want something that's going to work well, and so you need to understand how things correlate and what's going to affect the different weights in the algorithm. But also, and in this one, there's not really much of an ethical concern that I can think of because it's just wine points and variety. And but when you're building your models too, model explainability is an important thing to think about, and what is the ethical implications of what you're building. That should be part of your data exploration every time.
Totally. That's huge. That was something we made sure we added into all of our deck, like slideshows for the tour last year, is that it seems like in all of this stuff, you know, whatever the results are, you need to be able to back up how you got to those results and like understand, you know, like showing your math type of thing. And then there's the ethical side of it too, and making sure that, you know, you're not creating something that isn't, that's causing some harm on groups of people or some unintended consequences with the things that we're trying to do. So super important stuff to keep in mind when you're playing with these large data sets and assuming that it's making predictions that are right.
Yeah, and so there's things that you can do to think about how it's predicting, and there's some model explainability tools. Microsoft has a really cool one that they're working on. I think it's in preview. And so using those different tools to think about it, but then also common sense. So one that I like to use as an example is GPT-3, which is a new one that just came out, which is it's kind of insane if you think about it. I recommend reading into it. But one of the problems with it is 60% of the data is pulled from this common, I forget what the name of the data set is, but it's basically just scraped from the web every day and put into this database, and then people can just grab it. Common crawl, that's it. So use this common crawl database. So 60% of the weighted training is this. And this database, I mean, you know what the internet is like. It just grabs that data, and it doesn't, from my understanding, do much cleaning on it. And so there is bias in this model. And now everybody's really exciting about it because right here, as you can see, it's the largest machine learning model ever created. It's 70 billion parameters, which is just like mind-blowing. Wow. They spent millions of dollars training it. I can't remember what they said, how long it took to actually train the model. It's insanely advanced. It can write code. Like it can mimic lawyers. It can do all kinds of stuff. So one of the cool things to look at it is that, yeah, it does all these crazy cool things that are cutting edge and seem like the closest to general intelligence. But then at the same time, there is harm in it because of the way that they're using the information. Like there's ways where so it's kind of double should be tested and everything. But yeah, so something to make sure you think about when you start building machine learning models. I don't know if I got lost there again or not.
Just for a little bit.
Okay. Cool. So there is that's my ethical data spiel. But here we're just, wanting to know if our wine's good. Mm-hmm. So the next thing I want to do is create a calculated column. So I could have done this. I decided to do this as a classification since I was doing classification on both the quality and the variety. And so I just decided to do 3 classification models. You could have done this as a regression model and actually predicted the point value. But instead, what I did is I took the quality points and I just created this method to actually bucket them, put them in buckets based on the points that they had. So if it's less than 85, I'm just saying, or equal to, or less than 85, I'm just saying it's bad. Less than or equal to 90, okay, good, great, right? And if this one got hit, I did something wrong because there shouldn't be anything over 100 in here. So I will go ahead and run that one.
While that's running, Cassie, we got a question in chat about calculating. I don't know if you can see the chat.
Yes.
Just what your preference is between using the coefficient between the variables. I'm not sure if I understand the question exactly.
Done for points versus price, how to preferably coefficient between variables. So these are text, since I'm creating them into buckets, it's just a text, it's like a classification. So the class would be okay, good, bad. And then same with the price range. So I don't think it's something I needed to worry about from what I understand in your question.
Yeah, that sounds right too. And then another question too is, do we do any front end development? Which I would say I don't do a lot unless you're talking HTML, CSS stuff, JavaScript, but a little bit of JavaScript. But I know Cassie's all over the place.
I am all over the place. That's a really good.
We all are, but you're like above and beyond with all this machine learning stuff and Python. And we lost her again.
JavaScript, front end and back end and databases, and now I focus on AI. But I've definitely done a lot of web development in my past, and I still really like it. So yeah, this is a Vue site that I set up and did the design and everything. So please be kind because.
Yeah. And also to the question, is this channel, I believe the Microsoft developer channel in general, do we focus on front end stuff? Yes, there are many different shows. This is just the one we are doing, focusing on a variety of stuff, but leaning into Azure type of things in general. But yeah, stay tuned, or check out the channel every once in a while. You'll see all kinds of cool stuff.
Yeah, definitely. There's so many cool things, and actually even the old videos, like if you look at the bottom, like they have all the old channel or all the other streams that they've done, and then they also upload them all to YouTube on the Microsoft developer channel, so they persist forever. And so there's a lot of good content out there that has already streamed that you can go look at as well.
Over on the Channel 9 YouTube channel is where we put everything for perpetuity, forever.
Definitely. Oh, and if you want, so on October 14th and 15th, we're having a conference for getting into development if you're wanting to learn more about development in general, but a lot of it is front-end technologies like JavaScript, and but there'll also be cloud and databases and all kinds of fun stuff. So that's another thing that we're going to be doing, and it'll be streamed on the Learn TV channel, and I think also the Microsoft Developer Twitch channel as well.
Sweet. You can give me a link for all that. I'll include in the show notes after we're all done here today.
Yeah, so the site should be up tomorrow. So hopefully I'll be able to give that to you tomorrow.
Perfect.
Okay, so I'm applying this get quality function to my data frame points column, and I'm creating a new column in my data frame called quality. So one of the things I think is really cool about the data frame is it's really simple. Like to create a new column, I literally just have to
While she's coming back, I believe it's DF is short for data frame, and you're just establishing the name of those.
So balanced, I have more.
You're back.
What's that?
No, I was
Okay.
I was trying to use my own automated machine learning and predict what you were about to say right as you were cutting out. That that the DF is short for data frame, and then we're just creating our columns there, and then choosing what, I guess, not the name of it is, but what to do against it.
Exactly. Cool. So yeah, and so we have some different ways to visualize that and take a look. This makes it look a little bit less unbalanced, and with the cap plot, so I'm not too concerned. I could do something called SMOTE, which is a way to resample classes that are under distributed. So like if I wanted to get these more balanced, I could do something like that, and then that would then help. And the reason that's important is because if you have unbalanced data, your model may overly predict the more probable class. And so it'll look like your model's predicting really, really well. But in fact, if you're doing a binary classification where the answer is like yes or no, and like you have way more data for yes and not no, it's going to look like it's performing really, really well when in fact it's just unbalanced.
Yeah. Yep.
Okay, so then the next one I want to do is I'm just going to create some price range buckets. So the same kind of idea, but with the price range instead of the quality. And I'm going to then create that column for price range, and I'm going to apply this function that I just created. And so then this one, I'm just going to do a group by. So I'm going to group by my price range column and then show the size. So this is the amount of each of those, just to kind of see how they're distributed. Again, you can see that there's more in the 1 to 30 than there is in the 51 to 100 and then or to the above 100. So again, with this model, I don't think it really made much of a difference to change that around or to resample it. And it wasn't something I was really that concerned with because, again, we're just playing around with wine data.
Yeah.
But that could be something that could be affecting your
Yeah, it's kind of similar to the problem of when you're, I guess, going for the mean. Like we talk about in incident response, the value of mean time to resolve, mean time to recover. But the fact that there could be some data on either ends. Sorry, you just came back. I was trying to like use your example and say I've seen this type of thing too, where in data when we're analyzing incidents, if you start to like focus in on the mean time to resolution, you're not really seeing a true picture of what's happening because you might have had one outage that was like for 10 hours, but the other 500 incidents you had were 10 or less minutes, but your mean time to recovery is going to be astronomically high. But the more data you have, then that starts to normalize.
Exactly. The more data you have and the more good data you have, throwing out bad data can also really help your accuracy as well. So one of the things I was saying just about the varieties is there's some more obscure varieties, and so they're less likely to be around. And one of the things I thought about was either throwing out some of that data and just worrying about the more traditional ones, or maybe some of them could be like a blend, and so maybe it would be more sense for that one to be listed as, I don't know, Cabernet or Chardonnay or something like that. So like if you can see, there's actually 707 types in the variety column. So, and that's the type of grape that was used.
Wow.
So, like, I didn't think I knew before I did this that there was that many varieties.
No. I thought there was white grapes and there's red grapes. And you can get them with seeds and not.
That's what we should do. We should do white or red. Then we do binary class.
Exactly. I mean, for the longest time, wine to me was red or white. That's all I knew.
Works for in the SciKit Learn machine learning library. So we're using SciKit Learn. If I click over here, am I cutting out again?
Yeah, it cuts out every few minutes. I usually just try to jump in and talk for the 10 to 15 seconds or whatever until you're back. It's no big deal.
Bummer. Okay, I'll have to figure out what's going on with my internet. So the machine learning library that we're going to be using is SciKit Learn, which is a really good starting place, I think. Yeah. And then within it, we're going to be using something called the count vectorizer. So essentially what this is going to do is it's going to take our text and it's going to turn it into numbers by doing different processes, which I'll talk about what they are. But the important part to think about, and what for me, one of the light bulbs that went off when I started understanding machine learning, and in particular natural language processing, was that in order for the computer to run on it, it needs to turn the words into a number format, because computers understand understand numbers, right? Yep. So in order to run them through the algorithm, you have to do that. And so this count vectorizer does a lot for you, which is also called word embedding, getting that the word to a numerical vector representation. So in here, if we take a look at some of the things they have here, this is what it does by default. So if you just call count vectorizer, these are the default parameters. And I'm just on the SciKit Learn site here. I'll paste it. So we do a couple things. Let me go back to my notebook. So one thing is the lowercase thing. So everything's lowercase. You don't have any issues with that. For example, if you have red, right? In this one, there's just this example of 2, 3 different or 4 different sentences. If you had uppercase R and lowercase r, that would be represented as 2 separate tokens, and we want them to be the same. So just putting everything lowercase, yep. Which I'm sure we've run into in our development background, right? You have an error because one was uppercase and one was lowercase. So there's straight up goes all lowercase, and you can change that to false if you want. You don't have to use that. Another thing that it's doing for us is removing stop words. So this, and, in. And you can define your own stop word dictionary as well of terms that you want to be removed. And so what this is doing is actually cleaning our text in a way that's able to create that vector in a way that is more efficient and actually works better for the overall accuracy of our model. Another thing that's happening is the n-gram tokenization. So I think this is another interesting thing. So you can set your n-grams to 1, 2, 3. And essentially, if you take a look at how it breaks that up, it's tokenizing in the length of the gram. So if it's 1, then this is a sentence, and each one of those would be a separate token. If you have 2, and you can actually do a range too. You can say, well, I want it to be both 1, 2, or 1, 2, 3, and it would tokenize that same sentence all those times. But then what you're giving up is the size. The more you have, the bigger the model is. So sometimes you're playing with the balance of getting as much as you need to get a good prediction, and not too much without actually giving it a better prediction, but still being able to get what you need in order for the model to understand the sentence in order to make those classifications. Mm-hmm. So then the next thing it does is lemmatization. Oh, wait, sorry, actually, so I thought count vectorizer does this for you, but it actually does not. Lemmatization and stemming is something that you'd have to do separately outside of it. But essentially, so words like fruity and fruit and fruitiness, as you have in the example here, could all become fruit because fundamentally they're all the same root word. Right. And so then now that means that all of these different words are down to this one root word, and it can classify on that. Again, you're getting more efficient and more direct results in understanding. But the count vectorizer actually doesn't do that for us out of the box. It does all the other ones. Okay. And then what it does is it takes in all of these parameters and it creates the text or the corpus. So it's going to create that vector of the tokens that we want to use to actually process our text. And I'll show you that down here too. Okay. What was the other thing? Oh, you can statically send in a vocabulary as well. And so this is kind of a cool trick that you can do. So this is automatically creating my vocabulary for me based on these parameters that I'm sending in. Mm-hmm. But let's say you know exactly the words that you want, or you want to add some in that you want to be exactly what you want. You can actually statically define the dictionary of the words it actually cares about, and everything else gets thrown out. Oops, my hand talking. I hit my mic there.
You get so excited and animated talking about these things.
What's that?
I said you get so excited and animated. You just your hands go crazy when you're talking about all these things.
It's true. I'm a hand talker. That's why my water and my coffee and everything is way over to right, because I have to keep this area clear.
Exactly. For dancing, for just talking. You don't want to knock things over.
Exactly. It will. And it has happened many times, which is why I've learned to keep them out of the danger zone. Okay. So count vectors. Oh yeah, statically defining your vocabulary. I actually had a model that I was working on for help desk ticket classification. So very similar idea, where I wanted to decide when a IT request came in from the business side, who the ticket should actually be assigned to. So the class were the different developers that could resolve the ticket. And instead of dynamically creating my vector through just letting it create it based on these parameters, I was like, well, I really care about these particular words because they have to do with like the application that's being worked on and this and that. So by actually adding in my static dictionary, my accuracy went way up. In this particular one, I don't think it would have much of an effect. So this one, it doesn't make sense to that, but that's kind of an example of like when you're thinking through building these models and you're thinking about your data and thinking about how each feature is going to affect the result. So now we're going to actually use this count vectorizer. I don't actually have to say lowercase true because as you saw, it's defaulted in there. The stop words are English stop words. So remember those kind of filler words that we're just going to remove out. And now I'm going to say the max features. So this means the total amount of words I actually want to vectorize. So 5 would not be what you would do for your production model, because that means it's going to throw out everything except for like the top 5 words is what's going to happen. But I want to do that because I want to show you how it's going to actually process it. Like, so how it goes from like this description into the vector. So I'm going to create this method. So you can see here as well, like I played with different vectorizers, where this one you can see where I have my n-gram range of 0 to 2 or 1 to 2. My max features at 5,000 or 4,000. And then I was playing with some stemming tokenizers. So you can define your own tokenizer and then send that in to get some of that additional functionality that isn't out of the box in the count vectorizer. Okay, so we got that. And then I'm going to now call that. I'm going to send in the description because, again, the description is our feature. That's what we're using to predict our points and variety. So that's going to return back my vector and my vectorizer. And if I were to print out my vectorizer, you can see exactly what it's understanding, right? And if I get my feature names, these are the top 5 words in my text. So my aromas, flavors.
Yeah, those are all my buzzwords when it comes to wine.
Yeah.
Wait, where's the rind one though? That's the one I said earlier.
The rind? I don't know. We have to add some more features and see. That was a good one though. Okay, so now that we have this vectorizer, if we look at the array of the vector, you can see that, and this is on the description. Actually, did I forget to add the description on this? This means the vector is only the words. I think I forgot to print out the description so you can actually see it. Oh, there it is. Okay. It was one more down. So this is the description that we're actually looking at and that we want to vectorize and see. So if you take a look at where the words are that we have listed here. Let's see here. So aromas, I think I actually did. No, I didn't. Okay. See, so we have fruit. So we know that would exist in this one. We have, is that the only one? Nope, here's aromas. So we have aromas and fruit. We know those are going to exist when this gets vectorized. Are those the only 2? So if we take a look at the vocabulary, this is the dictionary. So these are how they're represented as numbers. So now aromas is now the number 0, fruit is the number 2, palate is 3, wine is 4, and flavors is 1. I'm not sure why those come out in not the correct order, but we're going to go with that. And now if I were to take that description, this is how it's now represented as numeric values in order to put it through our machine learning model.
Pretty simple.
So if you see 0, there's 1 occurrence, which is aromas, right? 2, fruit, 1 occurrence, and 3, palate. So where do we miss? Oh, there's palate. And so you can see the only words that it's ever going to look at are those 5 words, because everything else is going to get thrown out, which again wouldn't make a very good machine learning model, right? Because that's not going to really get a good understanding of what's in it.
Uh-huh.
But it's a good way to understand how it's able to take this text description and understand the values.
Okay.
So if we go back to our vectorizer and let's do, I want to do 4,000. Let's like do, because I don't know how long that will take to run. It might take a minute to run.
We've got a question in chat.
Yeah.
Cassie, about difference between count vectorizer and word2vec or glove.
I do not have a good answer for that. So, sorry, I can look up word2vec.
Are you familiar with either of those other two, word2vec and glove? Oop.
I've heard so much text. What's trained? Oh, so that's just another technique versus like bag of words, from what I understand. And then glove. I love the thing when you like Google tech words that have normal meanings, and then you get like the normal result, and you're like, that's not what I meant at all.
Yeah.
Global vectors for word representation. Unsupervised learning for obtaining vector representations of words. Okay, so they're just different ways to vectorize your text. And yeah, I don't have a good answer for that because I haven't used them, but maybe I should try. It'd actually be fun to take this model and try these different ones and see if how they perform.
Stay tuned for part 2.
Yeah, exactly. Okay. Did that run? All right. If anybody has an opinion, I'm happy to hear theirs as well.
Yeah, Prink Pan was the one with the question. If you've got anything to share with us on that, we'd love to learn more about it.
I love when I have like people in the chat that are like the little fairy godmothers, or I don't know what you want to call them.
Yeah, we always learn something new from somebody in chat, I feel like.
Totally. Especially like when you've been doing something like one way, and and then the other thing is like this is classical machine learning. This isn't deep learning, and I'm using SciKit Learn and Count Vectorizer, which is kind of like, I think of it as like the hello world. Like it's a good thing to like get started to understand. But then there's other ways like using BERT, which is a pre-trained model to get you better results using transfer learning and using neural networks. And so I think it really depends on what you're trying to solve. Like I think the answer, even though I don't know those, and so I can't say I can answer it specifically, I think it still is the answer is like, it depends. What are you trying to do? What do they give you out of the box? And you have to make all those decisions.
What problem are you trying to solve? Yeah.
Exactly.
Yeah.
Exactly.
Well, thanks for the questions. We're all noobs at this stuff, but it's the cool thing is, I mean, I was definitely a brand spanking new noob last year when I took all this on, and it's very approachable, and there's a lot of good resources out there. And you don't really have to know Python, but you can pick up what you need to know. And then on top of all that, I feel like this type of role and just these type of skills are going to be more and more important because we're just creating data all the time. And that's like going to be like the most valuable thing in the world at some point.
Yep. It is like data is kind of like the new gold, I think of it, because there's so much of it out there. There's so much of it that isn't processed well enough in order to do different machine learning on, but like the more data we get, the more we're able to actually understand it and use it, the more we can do with it, right? And so that's why I think the GPT-3 is, even though there's definitely some bad bias in it, and that's a huge concern, it is still like cool on the way of what they were able to accomplish.
Yeah.
I wish that ethical concerns were more of the first thought versus an afterthought in machine learning.
Yeah. So much of this is so new. You don't know what the results will be until you've been down that terrible path.
So now you can see our description has a lot more value just by changing it to 500 words, right? Now we can see a lot more representation. Now it's harder to visually parse this, which is why I just did like 5. So you could see these are the ones. And then you can see that this has 2. So for 144, wherever that is in here, if we want to try to find it, we can see that it actually has the representation twice. So That means it occurs twice in the data set.
Mm-hmm.
So it's a cool way to think about and understand. So now let's actually train our model. Now we understand what's going on. So I'm going to, again, create my vectorizer here off that description. And then I'm going to set my label. So we're going to try to predict the quality. Now this is going to take longer because I have now 1,000 features. So it's going to take a minute to go through that, right? The bigger the model, the more time it takes.
Yeah. And we don't have a big VM running this either.
Yeah, no, this is actually running on my local machine.
Oh, okay.
And I have a Windows book too. And I can't remember off the top of my head, what is it, 1080? What is the graphics card on that? I can't remember.
Yeah,
nothing too crazy though. Like you could run this. And that's the other thing that's cool about doing some of these simple models when you're doing like your Hello World is you can just run it locally, where if you get into the big data sets and the large neural networks, you're going to need to figure out some resources.
Can it do this and stream at the same time? That's the question.
Yeah, exactly. This one you can.
If we blow up the whole show here, it's because of this.
Then there's this in SciKit Learn, you have your train test split. So I have my features and my labels, and I'm having them split that out into my training and testing data. And so with machine learning, we want to always test with data that we did not train with. Because if you think about it, it in the way that the model kind of like memorizes that data, it's right. Those weights are learned from the data that you give it. Mm-hmm. So if you test it on the same data that you train it with, it might actually look like it's performing really well when it's not.
Right.
So you always want to split it out to have some test data and some, that's fine, the warning there. And so have some test data and some training data, but then also test it on in an environment where you can actually, like a testing or staging environment where you actually can see how it can perform.
Yeah.
I think like all those levels of testing before you just put it out in production are important to see how it's going to react to real world data.
Is there I figure like somebody told me or I read someplace, there's a kind of a rule of thumb if you have a data set of like how much of a percentage you should keep for testing and how much you should save for actually using after you've created your models. I feel like I just asked that right as you were losing connection there, so we might have to repeat the question when she comes back. Did you catch any of that? Are you back now? I was just thinking too that we've been going a good long while here without having any disruptions. Are you back now?
I'm back now.
Okay,
I can hear you now.
Cool. Well, I was just going into this like really smart question, I thought, right when you were dropping off. But what I was saying was, I don't remember if I read it somewhere or somebody told me, but when you have a data set, aren't you supposed to reserve a certain percentage for don't do any learning on this data, just save it for other stuff? Is there like a rule of thumb on how much you should reserve for that?
Yep, there is. I mean, like 70-30, I think is kind of like the default split, but honestly, you could do 50-50, you could do 10 and 90. But yeah, you always want to have the split. And in every model that you do, you'll see like that's what that test train split model was actually doing here. Or what this is doing is actually splitting that out into my X train, my Y train, and my X test and my Y test. Mm-hmm. So that way, when I actually want to go down here, so then I'm calling fit and I'm training my logistic regression. It's a multi-class one versus all with an LBF GS solver. And then my models returned. And those are just warnings. Everything actually still ran okay. You can put something in Jupyter to suppress them, but I didn't, so don't judge me. So, and then here when I'm calling score, this is actually taking that test data and seeing how it performed on that data. So this is what we split out from our training data set, but we didn't actually train it on that data.
Okay. And we've got another related question in chat about splitting for validation.
You can, yeah. That's another way to split it. Or like I like to do the validation part after I've created it with the like in the testing environment, I guess is how I've done it, because what I found when I was building production models is like this was a good, the accuracy is like, it's a good indicator, but it's not like fact, and it can be really skewed. Like what comes back can be really, it can look like it's doing really well when it wasn't. And some of those are because of some rookie mistakes that I was when I was doing, because I was just teaching myself as I went. And so some of those was learning those issues, but then some of them's like, well, it's performing, you know, it's saying it's at a 71% accuracy here. I actually, when I go and test it down here, it's almost, it's performing really well when I test it, right? So like this is an example that I can grab from the quality, and the value is okay. And then I can actually now predict it. So here I'm calling the vectorizer and transform, predicting it in the classes, and then putting that out into a data frame. And granted, that could have been an item that it was trained on, so I should try this on new data, right? But it actually was performing pretty well. So I think it's a model by model basis, and but I think testing is really, really important. I think a lot of the things that we read about in the news about models that went bad, right, that had bias and it wasn't caught. I don't know, because I wasn't, you know, obviously involved in those, but I feel like if there was some testing that, another thing that I always, in my production models that I created when I was working as an in-house dev, is I would add a human or static programming sort of check into it. So like I would have, the result would happen. And for one that I was doing around medical, where it was like component classification, that one we actually had a queue. So it would automatically check for new things, and then it would put it into a queue, and then a clinical informaticist would actually have to go in and approve it or not approve it. Because I just think they shouldn't go completely unchecked, right? You shouldn't, there are issues, right? And then also when you're building those new models and you're testing them out, there's different ways to look at it that way. For the help desk classification one, who should this help desk go to? That one, you know, it wasn't as big of a deal, so we just put it, I actually had it printing out to a Teams channel, the results, and then an email sent to the person that was the most probable, and I could kind of test it that way because it wasn't as high impact. So testing and the validation sets and all of that is really dependent on the model and the problem you're solving and the amount of impact bad results can have. But I don't think enough people, at least from my experience, I have heard about static logic tests after a prediction is made, and then having a review system by a person, even if it's just some and not all, to see how things are going.
Yep, exactly. Does your dog want to come visit? And thank you for the questions.
There's another blog and article that I did on how to deploy this model. So how we were actually deploying it for this front end site. So if I go back, too many tabs open. Here we go. My notebook. This is the same models, different GitHub repo, but it's a way to deploy it using the Onyx runtime, which is things called the Open Neural Network Exchange. And essentially, you can use the Onyx format. So when you export your model, you can export it into different file format types, right? The end result of a model is a file, just like the end result of a program is a DLL, right? A file. So when you export it, there's different options for formats that you can export it with. And one of those is the Onyx runtime. And the cool thing about the Onyx runtime is I can actually then do my inferencing in C#.
Yep. And I just put the link to the to your GitHub repo in there too for that.
Awesome. And I should show the Onyx site too. You take a look at some of the optimizations and that they've made, which it's really cool. So I'll go back here, and then in order to do that, so I am still building out the model in this one, but I don't have the explanation around how the natural language processing is working. But what I do have is how to set up a pipeline. So setting up my count vectorizer and my logistic regression into a pipeline, and then from that pipeline, I'm actually able to export it to the ONNX format, right? So this right here, this is how I'm actually exporting it. If you're not familiar with pipelines in data science, or like data pipelines, which if you come from a DevOps background, you're thinking deployment pipelines.
Not the same. That was me. I was like, oh, I know pipelines. Nope.
Yeah, add it to like the list of like overused words in tech, like model and pipeline.
But like all that stuff is in what is now the designer, previously the studio, right? That's where all the pipeline, like you can create those pipelines. Am I thinking the right tool?
So you can create a pipeline multiple ways, but there are pipelines within the Azure Machine Learning experience. So you can register pipeline runs in here. So let's say I'm doing some stuff in my local Jupyter notebook. I can still leverage cloud compute and all the experiments and pipeline stuff in Azure Machine Learning. So if I'm building, let's say, a neural network locally, and like I said, if I'm doing something really big that my local machine can't handle, I can use the SDK and integrate flawlessly into the machine learning studio. And that's one way that I can do that is like, for example, if you're trying different hyperparameters and you're running it a lot and you're changing, maybe you're changing around how it's vectorizing, or maybe you're changing the amount of features or those different types of things, right? It actually keeps a full history of all those runs in the experiment.
Yeah.
And so you can see like what you changed and how it worked, which is really cool, all from your local environment, and you get like the really nice readout of what's happening.
Yep.
Thing to know about if you're doing data science. And like if I were to like really, really oversimplify them, I would think of it as like if you had a console application and you were calling different methods you want to execute in a specific order. Kind of one way to think about it, I think. But that's probably oversimplified in a way that I'm missing things. But like the first time I heard data pipeline, it was a confusing term for me because of the fact that I've heard pipeline used so many other ways outside of machine learning.
Yep, exactly. Yeah, I walked into definitely a wall with that one, thinking I knew what I needed to about pipelines, and then quickly realized not the same thing at all.
Yeah. Yep. Exactly.
But still super fascinating and interesting. I loved all the visuals. It helps you really understand what's going on behind the scenes, how many times it's run, results, all that kind of good stuff.
Yeah, and so when you are talking about your pipelines for machine learning, it's now ML ops, or machine learning ops is what it's more commonly called. So even your pipelines in machine learning aren't necessarily called it still is. It's still a DevOps pipeline, but I'm thinking they're calling it ML ops probably to like help with the confusion. But there's also more to it than just the deployment in the CI/CD, but stuff. Okay. So here is how I would actually convert that to the ONNX. That's it. I just set up my pipeline, I gave it a name, and I told it the type, the initial types. And from there, I'm able to take that and serialize it into a file, and that's my model. That's it. Okay. Now I have a model that I can deploy with Azure Functions using C#.
Excellent.
And if you're not familiar with Azure Functions, it's the serverless solution in Azure.
Yeah, let me see if I can find a link for it.
Yeah, that'd be a good link. Okay, so the one thing now I want to show you, I think I closed that. I'm going to go back to Designer, and I'm going to show you this basically the same concept of a model. But this is using the Designer, which is the no-code way to create machine learning models. And so if I were to go here Oh, let's see, the Azure function will be HTTP triggered. Yeah, you can actually trigger it multiple ways. It can be scheduled, HTTP. What are the other ones? Do you know all the different storage, I think, events,
Uh,
Azure storage events?
Oops, I was muted there. Yeah. What do they call them? Is it just event triggers? I think you can set up to kick off all kinds of stuff. But usually, yeah, HTTPS is the way I always do them.
Yep.
There's
And that's how
every time I go look, there's like a new cool way that I can trigger these things.
Azure functions, I just love them. Like
Yeah,
if I could write like a love letter to one of our services, that's probably really weird, but it might be Azure functions because it fulfills so many needs
totally.
in development that there like never was really an awesome way to do before. Like I think about jobs like the Windows task scheduler like on the server, and we'd have these like little exe files that would run on a schedule, and like they would fail and nobody would know that they're failing because
Mm-hmm.
there was like no good way. So then there was tools that you could do on top of that in order to get better information about how things were failing and what was happening. But like with Azure functions, it's just like all there for you, and you just have to create it and put your code in, and it's happy and pretty and lovely.
It just
So
works
anyway,
and
it just
cheap.
works.
It doesn't hardly cost anything.
Yeah, and it's cheap on top of it. And you can, so the other cool thing, like you can do your machine learning models here, and it actually can support large models now as well. And what was I going to say about that? Oh, the inferencing part, you don't need as much GPU and like resources as you do to train. So training, you need like all of the power depending on your model, right?
Mm-hmm.
But for inferencing, you can use a machine with a lot less resources because the inferencing doesn't take as much power. So that's the other thing that's cool about it. And when you're thinking about like cost, like your training and your development side is going to be more expensive.
Right.
Um, figures.
By the way, Cassie, I I know. Well, we're coming up on time. We've got about 10 minutes or so left, a little less. But I was looking through the Learn modules, and there's a ton of stuff on machine learning over in Learn. So I'm going to put a bunch of links into chat for people to go check those out too, because that's how I picked up on all this stuff so quickly. Well, that, and also I got access to Cassie, and I can like reach out to her and say, "Hey, I'm stuck. Teach me."
Yes.
But anyway, these Learn modules are fun.
Yeah, they are a really good way to get started. And I know they're always adding more. So that's awesome that you're putting those in there because that's a really good way to start. The other thing too is like even in the Azure Machine Learning service itself, there's a ton of samples. So like even if you were just to go create this, so you could go to the Learn modules and do that, but there's also sample code. If you go into the Jupyter Lab version after you create the cloud compute, there's a ton of different samples you can just kind of run and get and see how it all works.
Mm-hmm.
Which like when you're trying to learn something new, sample code I feel like is the best.
Yeah.
So if I go into Jupyter Lab again, and that's same with like the SDK. So maybe you're wanting to use the cloud compute, but still develop locally in your Jupyter notebook. You can use that SDK. And there's samples on how to use the SDK in here. It's also in docs as well. You don't have to create the resource to look at it. But the one thing I wanted to point out now for this was just the way that we were able to do, like if you think about high level that I can just grab and drag and drop. And so I could upload my data set either from Azure Storage, I can create a data store, I can upload it into Azure Machine Learning itself. And when we were talking about all those different ways to process the text, if you take a look, this has a nice UI to show you like, hey, I want to remove stop words, I want to lematize, or maybe I don't want to lematize. Maybe there's a reason why I don't want it to simplify my text in that way, right? Mm-hmm. You can even do some regular expression stuff. And so that's like that first step, that pre-process. And then if you think back to the split data, right? Because we're talking about splitting it. Here, this one's actually splitting it 50-50 for training. So it's actually doing the word embedding, so the vectorization, two different ways. It's doing n-gram features from text here. And if we take a look, you can see all those different things that we were talking about. I didn't talk about term frequency and inverse document frequency, but you can go read about that on our docs, or SciKit Learn has some good docs on that as well. You can say like the word length, again, like all these parameters that we were able to put into our vectorizer, you're able to use right in this model.
I love this. I love how there's so many new new things that are this no code drag and drop. Just get it done, build a proof of concept, get that minimum viable product off of your mind, and just start testing, playing around with it. It's so fast to like get an idea on into something.
Totally. I think so too. And I think that this is a good one too when you're starting out, because understanding the big picture of like, what are my steps to create this model and how do I get it to like work, right? And in here, you can think about the process before you jump into maybe the code part. Mm-hmm. And so here you can see this is the same classification. We used a multi-class logistic regression. And I was just able to pull that from the different modules or the algorithms that are available built in. Selecting the columns in our data set. So, and then it scores, evaluates, and runs, and then you can see something very similar. If you go to the designer here, the other thing that's really helpful is they have all these different pre-built models. So the one that we're actually looking at is right here. You can go in here and click this, and when you click it, it'll actually just create that model for you. And then you can start playing with it. So when I actually got started with machine learning, that's kind of how I started. And then I started figuring out, well, how do I put my own text in? So this is my data set, but I could put a different data set in here and start building out a model very similarly to get a pretty decent result. And then from there, I can create an inference pipeline and publish all without writing any code. And then the endpoint is what's created that I can use to then implement it into my application. Because really, that's the end result, right? We build the models, we put them in a place where we can use them for inferencing, and that endpoint is then integrated into our application. Mm-hmm. So, and that's the endpoint here that I created. Now this one, like I said, is using Onyx functions and C# for inferencing and having those 3 different models deployed to 3 different endpoints. You could put them in the same endpoint too. And actually, I might have put them in the same endpoint now that I think about it, because I want it to hit all of them every time I run. Yeah. So why not just do one call with 3 different models? I don't know. Should I close out? Is there anything else? Do you have any questions?
Yeah, we have I guess a question/request in chat from our friend Prink Pen. I don't know if you've got an answer to that one.
So could you please put your automated ticket assignment on GitHub? I can validate my solution against it. I'm not sure. The process, though, is very similar to how I did it with this wine reviews. I used Count Vectorizer, SciKit Learn, multi-class logistic regression. So all of that is pretty much the same. If that answers your question.
We missed just the very beginning of that. What did you say? There's not currently a repo, but this is very much similar to some of the other stuff you got?
Exactly. Yep. Okay. So it is, it's not an open source data set that I can share since I built it while I was working at a company. And so that's their internal help desk ticket data. But like I said, the process that I did is pretty much the same, grabbing the text, creating those features. Like the only thing that I did is for that particular one, creating a static vocabulary that I defined instead of having it dynamically created based on the parameters that I put into the Count Vectorizer worked better. But it was a multi-class logistic regression. And so you could take this same model and you could classify anything. Like I'm using text to classify, the text reviews to classify price points and variety in a multi-classification way. You could even, like I said, you could look at the points and the variety as a regression instead of a classification. But you could also put in a help desk ticket data set and update the parameters and everything, but it'd be kind of fundamentally the same process. It's a natural language processing model that you could use on really.
I want to say that there is a data set for that type of stuff, for like customer support ticketing, because I think we had some other demos. I know I gave a demo at some point that was, using that type of data, but I can't remember what it was predicting. It was something about type of problems that they were seeing. Anyway, I don't know the details, but I would say go onto that website, Kaggle, and see what's in there as a starting point, because it all starts with the data, right? When a guest freezes and their face is yeah. Okay. Yeah, we cut out just for another moment there, but I think that answers our friend's question. So thank you for that. And I would go check out Kaggle and see if you can find a good data set there and start from there. So what else in like the 2 minutes that we have before we get thrown off the channel? Do we need a follow up? Like where would we go next that we have this? Is there anything more to do or?
You would deploy it to your site. So, like I said, I did mine in Onyx with with Azure Functions. And so I have this blog post that was put out, and we'll share that resource link.
Oh yeah. Let me get that.
Should I paste it in? Or?
No, here, I've got them both right here. I was just gonna do them one at a time. So cool. You've got that whole pretty much a lot of what you talked about today is over on this article, right? The Grab Your Wine, very similar name, and then the one about Onyx, that it's not Pokemon.
Yeah.
Is right here. So go take a look at those. Very well written.
Thank you. So yeah, those show you how to set up an Azure function using an HTTP trigger, how to use Azure storage for your models, to then just load them up, inference, and also how to save them to your. So one of the things that I ran into is like, well, I don't want to have to go get that model every time I need to use it, so it can cache it in the instance as well. So it kind of goes over how to do that with Azure functions. There's some new things coming out with Azure Functions, and actually maybe they're not even that new, but I think there's a way where you can actually attach and detach a file store as well. So rather than grabbing them from your blob storage instance, like I'm doing in this blog, there's other ways to actually grab your model. So I've been meaning to look into that and see like if there's a better way to do it. But the way that I'm doing it, and it works great, is to just connect to my blob storage container, file stream that up, and then save it to that instance so that it's readily available.
Excellent. Well, Cassie, we are out of time, but I have enjoyed every minute of it, every second of it, even though we had a few dropouts, including maybe right now on our connection. But that's just how streaming works, and we do our best to get through it. But thank you to everybody who joined us on the stream today. We've had some good questions, and now she's back. I was just saying thank you, Cassie. Thank you to everybody on the stream, anybody in the chat. And I'm sure Cassie and I will do another one of these in the future, so stay tuned and follow us here on the Microsoft Developer Twitch channel, as well as go check out Microsoft Learn TV, where we're working on the process, smoothing that out. Hopefully by tomorrow morning, when I do another one, we'll have all that worked out and we'll be at the right resolution. So yeah, join me tomorrow. I'll have Neil Peterson. We're going to be talking about, I think, some Kubernetes stuff. Should be super fun. Awesome. And with that, I'll say goodbye. So thank you, Cassie, and thank you, everybody. We'll see you next time. Bye.